Okay, so today we are looking at the derivatives for inverse trig functions. We're looking at the derivatives for inverse trig functions. Okay, so if you are given that number one, if you're given that if we're given that y is equal to the sine inverse of x, okay, y is equal to the sine inverse of x, then we can write this equation as sine y is equal to x, and then now the function becomes an implicit function. So if you have to differentiate it, you're going to use implicit differentiation. So let's differentiate this function here. So derivative on this side of sine y will be cos y times dy over dx equal to derivative of x is 1. So from here now you make dy dx the subject to the formula. You're going to have dy over dx will be equal to 1 over cos y 1 over cos y. But we know that from here we know that if you have cos squared y plus sine squared y, this is equal to 1, then we can have cos squared y being equal to 1 minus the sine squared y. And then now let's make cos y the subject. So introduce the square root on both sides of the equation, the square root this side, then the root, and that will go remain with cos y being equal to the square root of 1 minus sine squared y. Okay, so we can write our dy dx as dy over dx will now be equal to 1 over the square root of 1 minus sine squared y. But remember, recall that we know that the sine y is equal to x. That's what we said at first from this we say we can see that sine y is equal to x. So while there is sine y in the dy dx here, we can have y dy over dx will now be equal to 1 over the square root of 1 minus sine y is what? X. So you're going to put x squared. So this is the derivative of the inverse trigonometric function for sine. So from this we can conclude that number one, so if y is equal to sine inverse of x, then dy over dx will be equal to 1 over the square root over 1 minus x squared. By the way, the value of this x should be less than 1, even here. Okay, x should be less than 1 for this to be defined. 2 if y is equal to cos inverse of x, okay, then dy over dx will be given by negative, the opposite of this, negative of the same thing as x1 minus x squared. Even this, the values will be like that. Let's go. Number 3, if you have talked about sine inverse and cos inverse, obviously the next step is to talk about tan inverse. So if y is equal to tan inverse of x, then dy dx will be given by 1 over 1 plus x squared. So now this will be true for all the real numbers, okay? This will hold. This, all the values of x, okay, will be under real numbers. They will hold. Number 4. So if you talk about tan, you can also talk about cotangent, cot inverse of x. Then dy dx will be given by 1 over negative, just like 10, but negative plus x squared. Okay. Next, let's talk about, if you talk about all these, the obvious trig function that you can talk about is when y is sec inverse of x. Okay, so our dy over dx will now be given by 1 over the absolute value of x times the square root of x squared minus 1. Okay, let's also now talk about number 6. If y is equal to the cosec inverse of x, okay, so dy over dx will be given by negative 1 over, just like sec, 1 over the square root of x squared minus 1. And these are the derivatives. Let's do now some few examples. Okay, so now example number 1. Okay, if you're given, say y is equal to cos inverse of x squared plus, let's say 3. Okay, to find dy dx, find dy dx derivative. To do this, we let u be equal to x squared plus 3, so that your y now is going to look like this, cos inverse of u. Okay, this is a composite function because another function is contained within another function. So the dy over dx, okay, will be given by dy over du, sorry, du, dy du over du, dy dx will be given by dy du times du dx. So let's find dy du. What is dy? Oh, dy du, this is equal to derivative this is equal to the derivative of this. Okay, derivative of that will be, we know that the derivative of cos inverse is given by negative 1 over square root of 1 minus x squared, but we have u there, so u squared. That is the derivative of cos inverse. Yeah. Next, let us find du dx. Okay, let's find it on the side here. Du dx will be given by, what is our u? Our u was given by y is equal to x squared plus 3. So differentiating du dx will give will be given by, you drop the power, you get a 2 there, reduce the power by 1. This is our du dx. So let's substitute the du there, the dy du there, and then also the du dx. What are we getting? So our overall dy dx will be dy dx will be dy du is negative 1 over the square root of 1 minus u squared times the du dx is 2x. So simplifying this, you're getting minus 2x over square root of 1 minus u squared. But what is u? Okay, so our dy over dx, the final answer will be given by minus 2x divided by the square root of 1 minus, what is u? U is x squared plus 3 squared. So this is the overall solution, the final answer to the question. Let's do another example. If you are given, let's say, given y is equal to, say, tan inverse of the square root of x plus 1. Okay, so first step is to find y dx. First step is to let u be equal to the root of x plus 1. Okay, so that your y will now look like this. Your y will be tan inverse of u, and to find dy over dx, you should get dy over du times du over dx. So let's find dy, du, and du dx. Let's find those. Let's find those. Dy over du will be the derivative of this. For tan, we know it is 1 over 1 plus x squared, but we have u there, so u squared. Then for du dx, du dx, we should get, remember, u can be written as x to the power 1 over 2 plus 1. So differentiating this, you drop the power, you get 1 over 2 times x 1 over 2 minus 1 plus derivative of 1, a constant, is 0. So simplifying this, you're going to get x power negative 1 over 2 over 2. Let's simplify that further so that we can have this to be equal to this is power is negative, so you can write this as 2x power positive 1 over 2, which we know as 1 over 2 square root of x. So this is 1 over 2 root of x, the derivative of u. So substituting in this formula now, okay, so dy over dx will be given by, what is our du is 1 over 1 plus u squared multiplied by, what is du dx is 1 over 2 root x. So we're going to get this is going to be 1 over, because this is 1 times 1, okay, and then everything here times that, so that you obtain 1 on top, and then at the bottom you get square root of x times 1 plus u squared. So what is our u? Substitute back the u. Okay, substitute the value of u. Here you have 2 root x times 1 plus, what is our u? Let me use a different bracket here. We should have 1 plus, what is u? U is x squared, not x squared, root of x, square root of x plus 1. This is the derivative, the final answer. No squared here. Okay, let me write it clearly. We should have 1 over 2 root x bracket 1 plus root x plus 1 squared, close the bracket. This is our dy over dx. Okay, thank you for your attention. I hope that will help you.